Hi, this is Team 19. Our project is distributed branch cache. Branch cache is a one-bandwidth optimization technology in which content obtained from servers can be cached on the client systems and shared between clients. This is our architecture. When a client wants to download some resource from the server will reply the file information for the first request, which include the hash code and file size. With those information, the client can first check whether this file has been cached before. If not, it will multicast the request to the peer nodes to see whether it can get the resource directly from its peers. If it can't, then it will download the file from the server directly and cache it to use it in the future. In the configuration stage, the client will do several things. It will read configuration from configuration file, then use it to build peer cluster. It will initiate cache file based on the log file in the cache space. It will retrieve all the latest available files metadata from the server. For the consistency in our system, the goal is to ensure the files cached in each node in distributed branch cache is consistent with those in the server. We have two methods to ensure this. First, we use hashcode to uniquely identify a file. In the backend cache space, we only use the hashcode to operate files. Second, before cache a new file, either get from the server or the peers, we will check the hashcode to ensure the consistency. For the consensus, to ensure this, there are 4 steps. In the first step, current node will multicast to all available peers to find who has cached it. In the second step, the peers will reply yes or no. In the third step, current node will request specific chunk from each node to ensure there is no miss and no duplication. In the final step, the peers will send back the data of the chunk to current node. For the algorithm to ensure fault tolerance, first, the files are split into chunks, and the chunk indexes are stored in a stack. Second, we fetch k parts each time, where k is the number of available peers that have cached the requested file. Third, we will refresh the peer list before each fetching, and we will pop the chunk numbers from the stack. And finally, we will check the size of the fetch data, and if it is less than expected, we will push back the chunk index to the stack, so this chunk will be fetched again in next round. For the skill challenge in our system, we use Python, we use HTML5 in our system, and we design how to operate the file and design the communication protocol in our system. And the most important and challenging part is the video streaming display in the browser. For the team organization, we split the whole project to independent parts, but we will work together when we work on related parts. We have 1 or 2 meetings per week. Since we have students in Pittsburgh and Silicon Valley, we use Google Hangout, Trello, Google Docs to cooperate with each other. And the job splitting is not easy, so it's hard to estimate workload. But if we will do this again, we may want to start it early. Thank you.